Hello everyone. In this video, we are going to look at more examples on principle of mathematical induction. Here we are asked to use induction to show that 4 raised to power n minus 1 is divisible by 3 for n equal to 1 to 3 and so on. Okay, the first thing is the basic step. We start with the basic step. Now in the basic step means that n is equal to 1. So it means that if we have 4 raised to power n minus 1, we substitute 1 for n, we are going to have 4 raised to power 1 minus 1, which is equal to 3. You can see that the number we got is divisible by 3. Okay, so that means the statement is true for n equal to 1. Just like we see here, statement is true for n equal to 1. Okay, so now we go over to the inductive step. For the inductive step, 4 raised to power, your n becomes k. That means we can say that 4 raised to power k minus 1 is divisible by 3 based on induction. Okay, divisible by 3, just like we have here. So we now continue for 4 raised to power k plus 1. Now let's do that quickly. 4 raised to power k plus 1. Now for 4 raised to power, for k plus 1, your 4 raised to power n minus 1 will now be 4 raised to power k plus 1 then minus 1. 4 raised to power k plus 1 can be written as 4 raised to power k times 4 raised to power 1 according to indices, then minus 1. Now I'm going to I can rewrite it as 4 raised to power k into the 4. There can be 4 plus 1. 3 plus 1. Now the reason why we are doing this, the minus 1, the reason why we are doing this is that we need to get back our 4 raised to power k minus 1. So I made this 4 here to be 3 plus 1. That's because if we open the bracket, I'm going to have 4 raised to power k times 3, okay, plus 4 raised to power k times 1 will give us 4 raised to power k. Then you see minus 1. Now from what we see here, you can see that this 4 raised to power k minus 1 is divisible by 3 already by induction, by assumption. Then look at what we have left. 4 raised to power k times 3 is also divisible by 3, you see. So which means that the statement is true for all positive integers. Okay, so let's raise it here. You see, we have for n equal to k plus 1, you see that that's the value. That's the value. Then you have this. Okay, so let's see another question here. Hope this will give us understanding. Here we are asked to show that 10 raised to power 2n minus 1 then plus 1 is divisible by 11 for all natural numbers. Okay, let's start. We start with the basic step. Okay, let's see the basic step. And the basic step is that n is equal to 1. Okay, for that, we are going to have 10 raised to power 2n minus 1 plus 1. If I substitute 1, I'm going to have 10 raised to power 2 times 1 minus 1 then plus 1, which means 10 raised to power 2 times 1 minus 1 is still 1 then plus 1. 10 plus 1 will give me 11. You see, we got 11, which is obviously divisible by 11. So we can say that the statement is true for n equal to 1. Okay, let me rub this off. Let me rub this off. Okay, good. So you see that? So statement is true for n equal to 1. So the next is the inductive step. So here we assume first of all that it is true for n equal to k. That means this will now be 2k minus 1 then plus 1. You see that? So we can go ahead for n equal to k plus 1, which means that where I see k, I should put k plus 1. So in place of k, I put k plus 1, then minus 1. Remember, everything is still plus 1. So that will give us 10 raised to power. If I open the bracket, 2k will give me 2k plus 2 minus 1, and of course plus 1. So that will give us 10 raised to power 2k plus 1. Okay, then plus 1. Okay, this is what we have. Now, but if I want to get back to, I'll have to find a way to bring this out from my new value. And the only way I can do that is by writing this as 10 raised to power, let's say 2k minus 1 plus 2. Okay, I think that's good. 10 raised to power 2k minus 1 plus 2. Okay, because minus 1 plus 2 is still plus 1. Then remember, we already have a plus 1. Okay, let me rough some things off for space. For space. Okay. So this is what we have. 10 raised to power 2k plus 1, which I said we can write as 10 raised to power 2k. That plus 1, we can write it as minus 1 plus 2 minus 1 plus 2, because actually 10 raised to power 2k plus 1 plus means plus 1 means minus 1 plus 2. Remember, the idea is that I need to bring this out. This is my original equation. Okay, so remember, we still have plus 1. Now that will now be 10 raised to power 2k minus 1 plus 2 means plus times 10 raised to power 2. Okay, then so that will now be 10 raised to power 2k minus 1 times, that's minus 1 times 100. Okay, 10 raised to power 2 is 100, and everything plus 1. So this 100 now we can write it as 99 plus 1. Okay, in order to get back what we are looking for. So we are going to have 10 raised to power 2k, 10 raised to power 2k uh, minus 1 into 99 plus 1. Okay, then plus 1. Okay, let me rub some parts off. Okay, so let's rub the whole of this off. Okay, so if you open the bracket now, we are going to have 10 raised to power 2k minus 1 times 99 plus 10 raised to power 2k minus 1 and plus 1. So this is already divisible by 21 from assumption. By 11 from assumption. Then this is also divisible by 11 because of 99. Okay, so we can now conclude that the statement is true for all positive integers. Okay, so let's now see. Let's continue. That is it. That is it. That is it. That is it. Okay. That is it. Okay. Okay. You see that? Those are the steps. Those are the steps. Okay. So and that gives us our concluding answers. Okay. Thank you very much. I wish you the best. Please, you can make whatever comments on the comment section, like, and thank you.